Today we are going to start exercise 4.6 जिसमें हम लोग सीखेंगे जो how we can solve a system of linear equation using matrix method, right? अब देखो अगर
Yes, sir.
2 इक्वेशन दे रखा है या फिर 3 इक्वेशन दे रखा है, अगर कोई भी एक सिस्टम ऑफ लीनियर इक्वेशंस दे रखा है, उस सिस्टम ऑफ लीनियर इक्वेशन का या तो यूनिक सॉल्यूशन होगा, राइट, या फिर इनफाइनाइट मेनी सॉल्यूशन होगा या नो सॉल्यूशन। दैट मीन्स या तो कंसिस्टेंट होगा या फिर इनकंसिस्टेंट, राइट। सो फर्स्ट विल वॉच दिस वीडियो
Yes, sir.
टू अंडरस्टैंड द concept. So just okay. Okay, just watch this.
How do we solve a system of linear equations using matrices and determinants? How do we solve for the values of x and y here? So one way is by solving them using one of the regular techniques we have seen, or we can use matrices to solve them. Yes, matrices. To solve the equations using matrices and determinants, we first need to write them in the matrix form. So we first write the matrix of the coefficients. For the first equation, the coefficients are 2 and -1. And for the second, the coefficients are 3 and 2. This is the matrix of coefficients of the two variables. And for this will be multiplied with the matrix which has the column of variables. The variables are x and y. So a matrix with the coefficients multiplied with a matrix with the column of variables. And this product is equal to a matrix with the column of the constants on the right-hand side. That will be 4 and 13. This is the matrix form of the above system of equations. Why do we say that this is the matrix form? We will know why when we multiply these two matrices. Do you remember multiplication of matrices? To know if two matrices can be multiplied, we need to check their order. The order of this matrix is 2 by 2, and that of this one is 2 by 1. 2 rows, 2 columns, and 2 rows, 1 column. As the second and the third numbers are the same, these matrices are compatible for multiplication. The order of the resulting matrix will be the first number by the fourth number. It will be 2 by 1. So we multiply the first row of this matrix with the first column of this matrix and write the product here. And then multiply the second row of this matrix with the first column of this matrix and write the product here. What will be the product of these two? It will be 2x minus y, and the product of these two will be 3x plus 2y. This is the product of these two matrices. And this matrix will be written as is. Now you see why this is the matrix form of the system of equations. As these two matrices are equal, we can say that 2x minus y will equal 4 and 3x plus 2y will equal 13. Same as these two equations. But let's come back to the important point. How does writing it in matrix form help us solve the equations? Let's see that on the right-hand side. This can be written as A times x is equal to B. We have called this one matrix A and this matrix x and this matrix B. A times x is equal to B. What we're interested in is matrix x. That will give us the values of variables x and y. So to get x on the left-hand side, we multiply both sides with A inverse. We get the left-hand side as A inverse times AX and the right-hand side as A inverse times B. Now A inverse times A will equal the identity matrix. We get this. And we know that the identity matrix times any matrix will give us that same matrix. So the left-hand side will equal matrix X. And the right-hand side will be A inverse times matrix B. That's how we get matrix X. We multiply A inverse with B. So when we are given the two equations, we write it in this form, find the inverse of this matrix and multiply it with this to get matrix X. And that will give us the values of the variables. We will solve this example in the next lesson.
Okay. So from this video we got the idea. Okay. Now in this exercise, what things we are going to learn, that one by one I am explaining. Now application of determinant and matrix, that is actually application of determinant and matrix. Okay, so in this section
Yes, sir.
we shall discuss application of determinant and matrix for solving the system of linear equation in two or three variables and for checking the consistency of the system of linear equation. Consistent system means a system of equation is said to be consistent if its solution exists. Okay, so that is called
Yes, sir.
consistent, right? Now how we'll solve this? So solution of a system of linear equation using inverse of a matrix. So in video already we observed the we can express a system of linear equation as Ax equals to B. So here three cases will raise. Number one, if A is non-singular matrix. Non-singular matrix means determinant of A should not be 0. Right? Then it is called non-singular matrix. Then A inverse will exist. Then its inverse exists. Then we can write X equals to A inverse B. But case 2, if A is singular matrix, then determinant of A will be 0. That means A inverse will not get. Here two cases will raise. In this case, we calculate adjoint of A into B. If adjoint of A into B not equals to 0, okay, then solution does not exist and the system of equation is called inconsistent. Understood this point? This part? This?
Yes, sir.
Huh? Okay, fine. And second
Yes,
case,
I understood.
adjoint of A into B equals to 0 matrix, then the system may be either consistent or inconsistent according to as the system have either infinitely many solution or no solution. Okay, so these things we have to keep in our mind. Now we are going to start 4.6. So we'll start from question number 1. So exercise 4.6. Answer 1. Here x plus 2y equals to 2 and 2x plus 3y equals to 3. Now this system of equations can be written as Ax equals to B, where A equals to coefficient matrix. So what is the coefficient? 1, 2, 2, 3. And X will be variable matrix, that is X, Y. And B will be constant, this matrix for this constant, that is 2, 3. Now after that we'll check age non-singular or not? Okay. So first we have to find determinant of A, and that is equals to 1, 2, 2, 3, and we'll get 3 minus 4, that is equals to minus 1. So 0 is not coming. It means A inverse exists. If
Yes,
we'll get determinant of A not equals to 0, then we have to find the adjoint of, because A inverse we are going to find. So adjoint of A we have to find, right? So adjoint of A, how we can find? We have to find cofactor of A11, means minus 1 to the power 2, and it will come 3, that is 3. Then A12 means minus 1 to the power 3, and minor of 2 will be 2. So we are getting minus 2. A21 minus 1 to the power 3, and this is also 2. So minus 2 we are getting. Then A22. So minus 1 to the power 4. Then minor will get 1. So it will be 1. After finding all cofactor, we write adjoint of A. So we know that adjoint of A is what? A11, A12, A21, A22. It's transpose. You will not forget to write transpose. So we are getting 3 minus 2 minus 2 1, and it's transpose, right? So here we get
yes, sir.
3 minus 2 minus 2 1. So transpose same we got. And already we have learned directly also we can decide what is the transpose of A. How? We'll interchange diagonal element, and non-diagonal element sign will change. But here we'll find,
Yes, sir.
because in examination generally we are getting 3 cross 3 matrix. That means x, y, z. Okay, equation of 3 variables will get. Now adjoint we found. After that, A inverse. A inverse will be 1 by determinant of A into adjoint of A. So 1 by determinant of A, what we got? Minus 1, and adjoint of A, 3 minus 2 minus 2 1. Now multiply with minus 1, we get minus 3 2 2 minus 1. Then we'll write formula x equals to A inverse B. X means x, y, and A inverse we are getting minus 3 2 2 minus 1, and we have to multiply with 2, sorry, here 2 2 3. Now multiply these two matrices. So here x, y. Now if we multiply, then what will get? Minus 6 plus 6. And here 4 minus 3. right? So x, y, we are getting 0 and 1. So therefore, by comparing both the matrix, we can say x equals to 0 and y equals to 1. And check it is satisfying or not. Yeah, it is satisfying both the equation x equals to 0 and y equals to 1 if we put. Then we can observe left hand side equals to right hand side.
Right hand.
Right?
Yes, sir.
Acha. If 3 equation, then also method will be same. Okay.
Yes, sir.
Now one questions I am doing. If you will get determinant of A equals to 0. Okay. So these kind of questions, just choose which one, in which case you can get determinant of A equals to 0. So in question number 3 we will get, so I am showing answer 3. Answer 3, here x plus 3y equals to 5. 2x plus 6y equals to 8. Now, this system of equations can be written as Ax equals to B, where each coefficient matrix, so it is 1, 3, 2, 6, and x equals to x, y, and b equals to 5, 8, right? Now find determinant of A. So determinant of A, 1, 3, 2, 6. So 6 minus 6, here 0 we are getting. That means the system of equation has what? Either no solution or infinite many solutions. So we'll
Yep.
find adjoint of A. Since it is 2 cross 2 matrix, then directly we can write what I said. You have to interchange diagonal element 6, 1, and you have to change sign of non-diagonal element 3 and minus 2. Right. Now check last what condition I explained. If adjoint of A into B not equals to 0 matrix, the solution does not exist. The system of equation is inconsistent. After that you have to tell inconsistent. Now let us see. Adjoint of A into B. What we are getting? 6 minus 3 minus 2 1. If you multiply with 5 8. Now check, are you getting 0 matrix or not? First row, first column, then 30 minus 24. Second row, second column, minus 10 plus 8. Then it is 6 and it is minus 2. So clearly it is not equals to 0 matrix, not 0, it is 0 matrix. Little bit dark. O we can make it. It means system of equations is inconsistent. Examine the consistency. So equation is
Consistent.
Inconsistent. So this is one kind of questions. Here we have check it is consistent or not. Now one questions we have to solve, like either see 12, 13, 14, 15 and 16. How many questions? 1, 2, 3, 4, 5. These 5 questions very strongly we have to do, right? So one I am showing question number. It is better if I'll show question number 15 because this is the most important question. Then you will understand. If question number 15 I'll explain, then 11, 12, 13, 14 also will be similar type. So I'm showing 15. Answer 15. A is given, find A inverse. Okay. So A equals to 2 minus 3, 5. 3, 2 minus 4. Then 1, 1 minus 2. So first we have to find determinant of A. So 2 minus 3, 5. Then 3, 2 minus 4. Then 1, 1 minus 2. Now expand it. 2 into 2 minus 4, 1 minus 2. Minus of minus 3 and minor of minus 3 will be 3 minus 4, 1 minus 2. Be careful because one mistake if you will make, then you will not get answer. 5 into minor of 5. So 3, 2, 1, 1. Now 2 minus 4, here minus 4 plus 4, so this part is 0, plus 3 minus 6 plus 4 plus 5. Calculation you also will check. Okay, 3 minus.
Yes, sir.
So this part to 0. Achha, here we are getting minus how much? Minus 6, na? And here we get
Yes, sir.
plus 5. So what we are getting? We are getting minus 1. Just once again check 2 into here, if we cross multiply, then minus 4 plus 4, that means 0. Okay, correct. Minus 3 into minus 6 plus 4, so minus 2. Here we are getting minus of minus 3, it will be plus 3 or minus 2, so minus 6. Okay, correct. 5. 3 into 2, 3 minus 2 is 1, so 5. So minus 6 plus 5, that is minus 1. Because chance
Yes, sir.
more to in examination, okay, you will make mistake. So be careful about it. Now we have to find adjoint of A. So we have to find all the cofactor. So A11. So directly we can find, my first one will be positive. So if this you are finding, so here minus 4 plus 4, that means 0. Then A
Okay, sir.
1 2. Second will be negative. First positive, second negative. Okay. So if you are considering this, then here minus 6 plus 4. It is minus 2. That means plus 2. Then A 1 3. So A 1 3 will be positive. So here 3 minus 2, that is equals to 1. So like that, very clearly you will find A21. Now A21. So it will be first one positive, negative, positive, then this will be negative. So for second row and first column remove, then 6 minus 5, that is 1. So we are getting minus 1. Then A22. The next will be positive. So second row, second column if you remove, then minus 4, minus 4, minus 5. So minus 9. A23. So then next will be positive, negative, positive, negative, positive, negative. Okay. And minus 1 to the power, here odd is coming, so it will be negative. So second row and third column if you remove, then 2 minus of 2 plus 3, 2 plus 3, that is 5. So we are getting minus 5. Now A 3 1. So it will be positive. So third row and first column if you remove, then 12 minus 10, 12 minus 10 is 2. A32. Then A32 third column, third row and second column if you remove, then minus 8, minus 8, minus 15. How much? Minus 8, minus 15. So it will be, first of all, here to negative sign you will put. So what we are getting? We are checking this now. Wait. A31. A31 to be found 12 minus 10. Then it's minor, this and this it will remove, minus 8 minus 15. So it is minus 23. 23. Then A33, it will be positive. So here 4 plus 9, 4 plus 9, 13.
Yes, sir.
Now adjoint of A equals to, first you will write formula. Why? By chance if you make mistake, at least step marks you will get.
Yes, sir.
A21, A22, A23, A31, A32, A33. Now this is equals to, so it's transpose. You will not forget to write transpose. So 0, 2, 1. Then minus 1, minus 9 and minus 5. 2, 23 and 13. So this we are getting adjoint. After that we find A inverse. So A inverse equals to, first you will write formula 1 by determinant of A into adjoint of A. So it is 1 by minus 1, 0, 2, 1, minus 1, minus 9, minus 5. Here 2, 23, 13. It will multiply with, therefore A inverse, if will multiply by minus, then 0, minus 2, minus 1, 1, 9, 5, minus 2, minus 23, minus 13. Please check answer this part. It is correct or not. After that, second part will do.
Yes, sir. This is
From back side, just check A inverse. Correctly we got or not.
yes, sir. Correct.
Okay. After that, write this system of linear equation. First we'll write 2x minus 3y plus 5z equals to 11, 3x plus 2y minus 4z equals to minus 5, x plus y minus 2z equals to minus 3. Now this system of linear equation, 11 minus 5 minus 3. Now this system of
Sir, actually, the answer is wrong.
A inverse.
Yes, sir. It should be 0, 1, minus 2, 9, minus 23, minus 1, 5, minus 13.
Now once again tell, column wise you are telling.
Yes, sir. 0, minus 2, minus 1.
For row wise or column wise you are telling.
So column wise.
Oh, here we made mistake now. Here it is transpose.
Yes, sir.
We have not written transpose. It's transpose we have to take. So please
Yes, sir.
make one correction, because this, be careful. Here so I'm rubbing this. So its transpose you have to take 0, 2, 1, and this is minus 1, minus 9, minus 5, 2, 23 and 13. This is adjoint. Now A inverse equals to 1 by determinant of A into adjoint of A. So 1 by minus 1. So 0, minus 1, 2. Then 2, minus 3, 23. 1, minus 5 and 13. So if we'll multiply by minus, then we'll get, now please check, 1, minus 2, minus 2, 3, minus 23, minus 1, 5, minus 13. Now check.
Yes, sir. They have separated the values of x, y, and z.
No, that's what we are solving. This is, I'm asking, A inverse is correct or not, this part.
Yes, sir. Inverse is correct.
Now, this system of equation, this system of equations can be written as Ax equals to B, where A equals to 2 minus 3 5, 3 2 minus 4, 1 1 minus 2, and x equals to x y z, and b equals to 11 minus 5 minus 3. Right, now our A was what? Okay, just check just starting part, 2 minus 3 5, then 3 2 minus 4, and 1 1 minus 2. So already A inverse we found. So here we can write x equals to A inverse into B, and already we got A inverse, so we can write x y z. Now A inverse we are getting 0 1 minus 2 minus 2 3 minus 23 minus 1 5 minus 13 into 11 minus 5 minus 3. Okay,
Yes, sir.
now just multiply and compare both sides. So x y z. Now if we multiply first row and first column, then 0 minus 5 and plus 6. Second row, second column, minus 22 minus 15 plus 69. Then third row, first column, minus 11, then minus 25 and plus 39. Now tell me what we are getting. X y z. So what number we'll get? We'll get, first one is 1, second one what we'll get? This is 37 minus 37, so 69, and 37 if you subtract, then what will get? 2 32. Once again just check, second row into second column, minus 22 minus 15 and 23 into 3, 3 3 is 9, 3 2 is 6, yeah, plus 69, right? So
Yes, sir.
Inverse is correct or not? Minus 2 2 minus 20. Have you checked properly inverse?
Yes, sir. The inverse is correct. I think.
It is coming 32, and
So the middle element is 9.
that's why I am telling na.
No, sir. Inverse का middle element is 9.
So that's why I was here is minus, here is minus 9.
You mistook it as 3.
So you should tell it. Here 9 it is. Middle element is 9.
9.
So this is 9. That's why it is coming little bit odd. So it should be then second row and first column. Here 45 will come.
Yes, sir.
So 45 and 22, how much? 67. That's why I was getting odd number, like it is not it should not be 32. So here it is 67 or here 69, so it should be 2. And here if we calculate this, then it is here to okay 39. Our negative number will be 30, how much? 36. So we are getting 3. So therefore, by comparing both sides, we can say x equals to 1, y equals to 2, and z equals to 3. So you can understand during the examination, if these kind of questions will come, then if any entry you will make wrong, then you will not get proper answer, right? So
Yes, sir.
be careful about that. So here I'll end today's video. So determinants, almost all portions we covered.
Yes, sir.
One more video I'll make to show some good questions related to matrix method solve. One more video I'll make. Okay, so this video I'll end here. Okay.